Okay, so we're going to be moving this triangle inequality theorem in this section. Now, what I have here on my screen, I'm going to see if I can create triangles. The numbers that you guys see are the measurements of the sides. Now, the big side on all three cases, I put it in the middle. I'm going to see if I can create triangle. My idea on the first example, you guys see the measurements 3, 4, and 8. So those are the measurements of the sides of the triangle. I want to see what happens if when I add the two small numbers, right, 3 plus 4, if I add the two small numbers, what if it is less than the third side, right? 3 plus 4 is less than 8. Now here I can move my sides. As you guys can see, I can move these. Once again, those numbers represent the measurements of the sides. I want to see if I can create a triangle, and I'm trying to connect these. And as you guys can see, they will never meet. Those two sides will never meet, so I will not be able to create a triangle. So when the measurement, the sum of the two numbers, so if I add the two small numbers, it's still less than the third side, I will not be able to create a triangle. Now, on my second example, what if 3 plus 5 is equal to 8, right? What if the two small sides, the sum, the adding the two small sides, it is equal to the big side? Once again, the 3, 5, and 8 represents the measurement of my sides. I'm going to see if I can create a triangle. You guys can see I'm trying to close this, and I'm going to say they do meet. These 2 points eventually do meet, and they meet right there. But as we can see on the picture, let me highlight the picture. That's not a triangle. That's actually a line segment, right? It's not a triangle. So from the first example, if I add the two small numbers is less than the big side, I cannot get a triangle, right? The two small sides will never meet. Now, if the two small numbers, if I add the two small numbers and it is equal to the big number, I still cannot make a triangle. I can make a line segment, but not a triangle. Now, what if we can see the 4 and 5? If I was to add 4 and 5, I get more than 8. So, what if adding the two small numbers, I get more than the third number? And let me try to see if this thing closes. Let me see if I can make a triangle out of it. And I'll say, yeah, there you go. I can make a triangle out of it. So the rule here, the triangle inequality theorem says the sum, so adding the two smaller lengths of any triangle must be greater than the third side. I show you examples. What if they're less than the third side? Those two sides don't meet. What if they're equal? I get a line segment. But what if they're more? So 4 plus 5 is more than 8. I can get a triangle. So on your homework, you're going to get something like this. State if the three numbers can be the measures of the sides of a triangle. I'm going to give you three measurements, not in any order. So don't think I'm going to go from large to small or from small to large. They're just any number and a list of numbers. I'm going to add the two small numbers. 8 plus 7. It must be greater than the third side. So what I'm asking here is 8 plus 7. Is 8 plus 7 more than 11? Yeah, 8 plus 7 is 15. So yeah, 15 is more than 11. So yes, I will be able to create a triangle out of those sides. I'm adding the two small numbers, and it has to be bigger than the third number. I have question number 11 here on the screen, so let's take a look. My two small numbers are 8 and 1. What I'm asking here is 8 plus 1. Is 8 plus 1 more than 9? Not exactly. Right? 8 plus 1 is equal to 9. I will not make a triangle out of this. I will make a line segment. So nope, I cannot make a triangle. Let's take a look at question number 10. The two small numbers here are 6 and 3. Is 6 plus 3 more than 9? No. 6 plus 3 is equal to 9. But I was asking, is it more than 9? No. What about 6 and 11? Right? I'm adding the two small numbers. Is 6 plus 11 more than 18? Well, no, right? 6 plus 11 is 17. So you're going to be adding the two small numbers, and it has to be bigger than the third number. Don't forget to capitalize the first letter, so the N on the no or the Y on the yes. Another rule we're going to be looking at is this rule. Now, the cool thing on my program here, I'm using Sketchpad. You guys can, if you guys have a calculator, the TI Inspired, you guys have this program. Now, the cool thing of this program, you guys notice I have one side is 5, the other side is 8, the other side is x, but at the bottom I have that x is equal to 4.13. If I move this, the cool thing is that the value of x gets calculated. So it can make it big or it can make it small. Right? I can measure this program that I have, it measures the value of x. Now, my idea here is if I'm given two numbers, 8 and 5, I want to know what's the smallest possible value for x and what's the biggest possible value for x. Since this program is going to calculate it automatically, I'm going to say, all right, let me see. I'm trying to make x as small as possible. So 3.20, 3.15, 3.0, that's when I get a line segment. So it has to be more than 3. What if I go on the other side? Oh, so it seems like the smallest value it could be is 3. It has to be more than 3 though, because at 3 it becomes a line. So for a triangle, it has to be a little more than 3, whichever way I go. So I'm going to say x can go as low as 3, right? It has to actually be a little bit bigger than 3. That's the smallest possible value. What if I'm interested in looking at the biggest possible value of x? So see, 10 point something, 11.64, 12.13. So getting bigger and bigger and bigger. I'm trying to see what's the biggest possible value of x, and I get it there when it becomes a line segment. On this other side as well, the biggest number x can be is 13th, but then that becomes an x. That becomes a line segment. So I'm just going to say, all right, having these things said, these numbers given, I'm going to say x has to be between 3 and 13. Right? I just showed you guys. It has to be in between 3 and 13. Now, knowing the length of two sides of a triangle, the third side must be greater than the difference of the two known sides, but less than the sum of the two sides. All right, this mumbo jumbo, let me translate it to English. You guys might be wondering, how am I going to get these numbers, 3 and 13, if I don't have this program? I don't have Sketchpad, or I don't know how to use it. Now it's easy. I gave you 8 and 5 to begin with. If you subtract those two numbers, 8 and 5, right? 8 minus 5, that gives you the small number. Right? 8 minus 5 gives me the small number. What if you add the two numbers? 8 plus 5, that gives you the big number. So in order for you to get the small number, subtract the values that I gave you. In order for you to get the big number, add the two numbers that I gave you. Do notice though that I have x in the middle and I'm using the inequality, the less than sign. So let's take a look at your homework. How is your homework going to look like? Two sides of a triangle have the following measures. Find the range of possible measures for the third side. So I'm going to say two sides are 6 and 7. My third side, I'm going to use an x. I'm going to use less than sign. I'm going to put them in between, my x in between my inequality signs. And I'm going to say x has to be in between 1 and 13. Right? It has to be more than 1. It has to be less than 13. How did I come up with the 1 and 13? The numbers that I was given was 7 and 6. Subtract those numbers, and that's how you get the 1. Add those numbers, and that's how you get the 13. Some of you might be wondering, well, do I go for the subtraction? Do I go 7 minus 6 or 6 minus 7? 7 minus 6 gives me positive 1. 6 minus 7 gives me negative 1. Right? Will I get positive 1 or should I get negative 1? Do keep in mind, we're talking about the length of the sides of a triangle. When we're talking about length, you must be talking about positive values. So make sure you go 7 minus 6. right? You're dealing with positive values. So not -1, +1. Looking at number 15, since I have it on the screen here, I'm going to put my x in between two values, right? The numbers given are 10 and 12. I'm going to say x will have to be in between 2 and 22. The way I came out with the 2, I subtracted the numbers given, right? 12 minus 10, that's how I get the 2. And then if I add them, 10 plus 12 gives me 22. Once again, for the subtraction, make sure you go 12 minus 10 and not 10 minus 12. Because 10 minus 12 gives me a -2. I cannot have negatives when I'm talking about the length. When we talk about measurements of length, it's positive. All right, looking at question number 14, I'm going to say x must be in between 2 and 18. The way I came out with the 2 because I subtracted my values. The way I came out with the 18 is I added the values. And lastly, x has to be between 1 and 15. I subtracted my values to get the 1. I added my values to get the 15. It's all together. There shouldn't be no spaces anywhere. And don't forget that I'm using the inequality, the less than sign. So don't be using any other signs. That's how you're going to be typing in the homework.